Myself, Mrs. J. Ashwini, working as an Assistant Professor of Mathematics, V.V. Vanni Perumal College for Women, Virudhunagar. In this video, we are going to learn how to solve a linear programming problem using Simplex method. First, we see what is a Simplex method. A Simplex method is nothing but a method which is used to solve a linear programming problem involving more than two decision variables. That is, the Simplex method is an iterative procedure for solving a linear programming problem in a finite number of steps. The method provides an algorithm which consists in moving from one vertex of the region of feasible solutions to another in such a manner that the value of the objective function at the succeeding vertex can be less or more or the same than the preceding vertex. This procedure of jumping from one vertex to another is then repeated. Since the number of vertices is finite, the method leads to the optimal vertex in a finite number of steps or indicates the existence of an unbounded solution. Now we are going to solve a linear programming problem using Simplex method. The problem is maximize z equal to 4x1 plus 10x2 subject to the constraints 2x1 plus x2 less than or equal to 50, 2x1 plus 5x2 less than or equal to 100, 2x1 plus 3x2 less than or equal to 90, where x1 and x2 greater than or equal to 0. The first rule is to convert the given LPP into its standard form for solving the linear programming problem using Simplex method. So the standard form of the given LPP is, here given the three constraints are in less than or equal to type. So we can add three slack variables in order to convert those three constraints into equations. So here we are adding three slack variables S1, S2 and S3 to convert the three constraints into equations. So the standard form of the given linear programming problem here is maximize z equal to 4x1 plus 10x2 plus 0s1 plus 0s2 plus 0s3 subject to the constraints 2x1 plus x2 plus s1 equal to 50, 2x1 plus 5x2 plus s2 equal to 100, 2x1 plus 3x2 plus s3 equal to 90, where xi's and sj's are non-negative variables. Now we are going to form a table for solving the given linear programming problem using Simplex method. For that, first we have to check whether the given linear programming problem has an initial basic feasible solution. So here we have added three slack variables. So we can form a 3 cross 3 identity matrix which is the basis matrix. So we can start our initial iteration. The initial iteration, the first column CB, which is the cost corresponding to the basis matrix, and the YB, that is the variables contributing the basis matrix, and XB, which can be calculated by using the formula B inverse, that is the inverse of the basis matrix into the right hand side constant small b. Then the given decision variables x1, x2 and then the added three slack variables s1, s2 and s3. So here the basis matrix corresponds to the three variables s1, s2 and s3 which occupies the column yb. The cost values of the three variables in the objective function are nothing but 0, 0 and 0, that is the coefficients of the slack variables in the objective function. Next, xb can be calculated by b inverse into b, where capital B, the basis matrix, is nothing but the identity matrix 3 cross 3. So when we multiply that inverse of an identity matrix with the right hand side constants, that is 50, 100 and 90, we get the same values, that is the XB column has the values 50, 100 and 90. When coming to the coefficient of x1 in the constraint, all the three constraints have the coefficient of x1 as 2. When coming to x2, all the coefficients of x2 in the three constraints have the values 1, 5 and 3 respectively. And here comes the slack coefficients of the slack variables. For S1, we have the first constraint. So, in the coefficient of S1 in the first constraint is 1. For the other two constraint, its value is 0. For S2, the second constraint has the coefficient 1 and for the other two constraints 0. For S3, the third constraint only has the value 1. For the other two constraints, its coefficient is 0. Now we are going to calculate the value of Zj. In the top row, we have written the Cj coefficients, that is the cost coefficients of the objective function in the given LPP, which is the coefficient of x1 is 4, x2 is 10 and for S1 it is 0, S2 it is 0 and S3 also it is 0. So the Cj values here are 4, 10, 0, 0, 0. Now we are going to calculate the value of Zj, which can be calculated by multiplying Cb and Xj. So for the column x1, Cb into x1, summation Cb into x1. So 0 into 2 plus 0 into 2 plus 0 into 2, which is 0. Similarly for x2, since the values of Cb columns are all 0, we will get 0 for all the Zj values. Now we are going to calculate Zj minus Cj. So we have to subtract the values of Zj with the values of Cj, which is given in the top row. So Zj minus Cj will be minus 4, minus 10 and then 0, 0, 0. Next step is to check whether all Zj minus Cj values are greater than or equal to 0. Here we have got two values which is less than 0. If suppose we have any value less than 0, we have to choose the most negative one. So here minus 10 is the most negative one, which is going to make as an entering variable in the next iteration table. So x2 will be the entering variable. For knowing the leaving variable, we have to calculate the ratio. For that we have to divide xb by x2. Since x2 is the entering variable, we have to divide the values in the column of xb by the values in the column of x2. So 50 by 1, which is 50, 100 by 5, which is 20 and then 90 by 3, which is 30. We have to choose the minimal ratio value, which is 20, which corresponds to S2. The value which is present at the intersection of an entering variable and the leaving variable will become the pivotal element. Here 5 is the intersecting variable. So 5 is the pivotal element for the next iteration. So here CB, YB, XB, X1, X2, S1, S2, S3. So in the initial iteration table, we have in the YB column S1, S2, S3. The CB values are 0, 0, 0. In the XB column, we have 50, 100 and then 90. For x1, we have all the values as 2, 2, 2. For x2, we have 1, 5, 3 and then here 1, 0, 0, 0, 1, 0, 0, 0, 1. This will be the pivotal element, x2 will be the entering variable and s2 will be the leaving variable. Now we are going to draw another table CB, YB, XB, X1, X2, S1, S2, S3. Here S2 will be the leaving variable. So S2 will leave the basis and X2 will enter the basis. So here X2, we have to calculate this row values in this table first. For that we have to make this pivotal element as 1. For making this pivotal element as 1, we have to divide all the entries in this row by 5. Then only we can get 1 here. If we divide this row by 5, then we will get here 20. Here it is 2 by 5. Here it is 1. Here it is 0. Here it will be 1 by 5. And then here also it will be 0. Next, the cost coefficient of X2 is here 10. Next we have to make this entry, this 1 as 0. The rule is, as per the algorithm, we have to make the pivotal element into 1 and the element above the pivotal element to 0 and below the pivotal element to 0. So we have to make this 1 to 0. For that we are going to subtract this S1 row minus the elements we have calculated here. We are going to subtract. So for that, here S1 will remains the same. Here we have 50. So 50 minus 20, which is 30. Here it is 2. Here we have 2 by 5. So 2 minus 2 by 5, which is 8 by 5. And then here 1 minus 1, 0. Here also we have 1 minus 0, which is 1. And then 0 minus 1 by 5, which is minus 1 by 5. And then 0 minus 0, which is 0. Here the cost coefficient of S1 is 0. Next we have here S3. We have to make this element also to 0. For that we have to make this row multiply by 3 and then subtract that value from this row. Here it is 20. If you multiply this by 3, we will get 60. So 90 minus 60 is 30. And then here 2 by 5, we have to subtract this one. So 6 by 5. Here 2 minus 6 by 5, which is 4 by 5. And then the next value here is 3. So if you multiply this one by 3, 3 minus 3 is 0. And then here is 0. If you multiply it by 3, we will get the same 0. Here also we have 0. So the element here is also 0. If you multiply this one by 3, we will get 3 by 5. So here 0. So 0 minus 3 by 5 is minus 3 by 5. And then the last entry, here it is 1. So if you multiply by, here it is 0. If you multiply by 3, we will get the same 0. And then if you subtract, you get 1. So now we are going to, the cost coefficient is 0. Next we had to calculate the value of Zj. Zj equal to 20 into 100, which is 200, and then here other two values are 0, 10 into 2 by 5, which is 4, here 10 into 1, 10, here also 0, here 2, and then here also 0. Next we have to calculate the value of Zj minus Cj. Zj minus Cj will be, here Cj value is 4, here 10, here 0, 0, 0. So 4 minus 4 is 0, 10 minus 10 is 0, here it is 0, here 2, 0. When you notice, here all Zj minus Cj values are greater than or equal to 0. So we have reached the optimum solution. The optimum solution is nothing but x1 equal to 0. Here in the basis we have only x2. x2 value is 20 and here there is no x1. So x1 is 0 and maximum Zj is 200. So this is the solution. So this is the solution obtained. Here all Zj minus Cj values are greater than or equal to 0. Therefore, the optimum solution is attained. x1 is 0, x2 20 and maximum is equal to 200. Thank you.